You're listening to What Do Scientists Do? A show where we talk to expert guests and learn all about their favorite science topics. My name is Jessica, and today I get to talk to Michael Metzger, who teaches us all about the science behind batteries. How can we make electric cars better? What are the different kinds of batteries, and how do they work? Let's find out. So hello everybody and welcome to What Do Scientists Do? It's a show where I interview a different guest each episode and they teach us all about their favorite science topic. And today I'm joined by a very special guest. Could you give us your name and your pronouns, please?
Hi, I'm Michael Metzger, he, him, I guess, and I'm really happy to be here.
And I'm happy that you're here. What kind of scientist are you, Michael?
So, by training, I'm a physicist, and then I changed direction a little bit, got a PhD in chemistry, and now my research at Dalhousie is kind of in the middle, I would say, between physics and chemistry. So we do research on lithium ion batteries.
Cool. So lithium ion batteries, what kind of uses do those have?
Well, we're pretty excited about our battery work because, I mean, the nice thing about it is that it is very applied and that, you guys can find it almost in all aspects of your daily life. So, we all have our phones in our pockets, right, which use lithium ion batteries. Then I guess, the bigger scale would be to use batteries in cars, electric vehicles, and then you can even find like huge lithium ion battery systems that store energy from wind farms or solar farms for our electricity grid.
Cool. So what's the difference between lithium ion batteries and maybe other types of batteries? Like, are the batteries in your phone and in your remote the same?
Yeah, actually, so that's a good question. Definitely there are other battery types, like we call them primary batteries. They can only be used once. And they are often used in, you brought up remotes, right? These small electronic devices, which you don't use that often really, and you don't need to recharge. So you can use these primary batteries, and then unfortunately they need to be disposed of. And as you guys might be familiar, the, let's say, chemicals that are in there are not so benign for our environment. So we really try to move away from this primary battery technology. And especially, when you talk about larger devices like phones, cars, power tools, you want batteries that you can recharge, that you can use many, many times over. And those would be lithium ion batteries. So they are called secondary batteries as opposed to primary batteries because they can be used many times and you just have to recharge them to get the energy back.
Cool. So what are you trying to work on right now? Like, what is the goal of your current research or some of your current research?
Yeah, so we're pretty fortunate here at Dalhousie University where we do our research. So I should firstly maybe say that it's not only me who is working on lithium ion batteries here at Dalhousie. In fact, I am in a big team with two other professors. One of them is called Jeff Dahn, and the other one is called Changyan Yang. And together we have a big research group, I would say about 30 to 35 people, and we work in a partnership with Tesla. So you guys might be familiar with Tesla as a company that makes very nice electric vehicles. And of course, at the heart of all these cars is the battery technology, and we try to support them with their battery technology. So we do research on, I would say, all aspects of lithium ion batteries. And just to mention a few, so we're very concerned with the cost of current batteries. So if you buy an electric vehicle or your parents buy an electric vehicle, unfortunately, they are still very expensive. And a big part of that is the lithium ion battery, which uses materials that have a certain cost, and we try to use materials that are cheaper in the battery cells that we research here. So that's one thing. The other thing is lifetime. So we want to develop batteries that can really last for many thousands of these charge and discharge cycles that we mentioned before. And this can result in cars that can go like more than 1 million kilometers. We have recently shown this in our lab that something like that is possible. Very good batteries. And then we also work on increasing the amount of energy that is stored in a battery. We call that energy density. So we want to make them as energy dense as possible so that cars can go on a single charge, they can go a further distance. And then a big topic for us recently is to use more sustainable materials. We're really concerned, with things like cobalt or nickel, even lithium. The world has not an unlimited supply of this, right? So these are minerals that are limited and that need to be mined. And if we could, for example, replace lithium with sodium, which is very abundant, you can find that in seawater, and it's really very abundant in the Earth's crust, then it wouldn't be a lithium ion battery anymore. It would really be a sodium ion battery, but it would be much better for our planet because we have just a huge supply of sodium. So the batteries could be very cheap, and we could have a whole lot of such batteries to move all of our cars to electric vehicles and store a lot of renewable energy. So this is something we are actively working on.
So those all sound like things that would be super useful for everybody and for the world. You mentioned developing cars that can go over 1 million kilometers. Right now, so a gas-powered car, can electric-powered vehicles usually go farther in their lifespan or not as far as gas-powered vehicles?
So, this example with a car that could go 1 million kilometers, of course, that is not a real demonstration or so that we did, right? But we did develop the battery that would be needed to build such a car. And we showed in our lab, in continuous charge-discharge tests. So that is a bit different from what you would do in real life. So we just cycle the battery, let's say in a day, 3 or 4 times. And if we do that over many years, that amounts to so many cycles that you could calculate that a car, let's say if it would do 300 kilometers on a single charge, which is possible, it could go over 1 million miles. And that's 1.6 million kilometers. So this has been demonstrated with the batteries that we build here. And that means really that, what drives the electric vehicle is possible to achieve such a long distance. But of course, there are other parts in the car that need to hold up. So, a regular car, maybe after 300,000, 400,000 kilometers, is definitely at its end of life because other components just give in. But if you maintain a car well, then there is no reason, at least from a battery standpoint, why it couldn't go that far.
So it's really the other parts of the car probably that would stop it first at least before the types of batteries that you were looking at.
Yeah, but I have to say also that actually electric cars, they have less problems with things like brake pads or all the mechanical components that are used for what we call an internal combustion engine. So the engine that burns gasoline. These are very complicated machines, right? And in an electric vehicle, you can replace that with a much, much more simple battery and electric motor. So there are very few parts that can break down. So actually, in that respect, I guess electric vehicles have an edge over our regular combustion engine cars.
Cool. So I have a question more for you now. How did you end up becoming a battery researcher? When did you decide that was something you were super interested in instead of maybe pursuing a PhD? You said you did a PhD in chemistry and did physics before that, right? So why did you choose to make that switch? What kind of caught your imagination with batteries?
Yeah, that's exactly right, Jessica. I first did physics and then, was quite excited about all the concepts we learn at the university doing physics. So, there are many different careers that you can pick when you finish your studies in physics. But I was really interested to continue in science, so I decided I would stay at the university and do a PhD. And at that time, I definitely wanted to focus on something that can be applied to the world and, is not, let's say, topic in fundamental physics where you maybe study atoms and electrons and particle physics and so on, which is super interesting. But I wanted to do something which is applied and which actually can be used in industry and in our daily lives. And as so often, when you choose a career path, it's very unclear where you end up. It's really like a bit of a shot in the dark, I would say. But the one advice that I can give, maybe to all of our listeners, it's always important to, surround yourself with good people and people that are inspiring to you. So I was very fortunate to find my supervisor of my PhD, Hubert Gasteiger, at the Technical University in Germany, who's a scientist there working on batteries and fuel cells. And the topics that he worked on really kind of excited me. And I had the opportunity to join his group and do work on lithium ion batteries with two big companies in Germany, BASF, that's the biggest chemical company in the world. They make materials for lithium ion batteries. And then BMW, they, of course, are also interested in electric cars. So for me, at that point, I really knew that I kind of found the field that I wanted to stay in because it was the perfect mix between, interesting fundamental research that you can also apply to real world problems.
Cool. So you kind of found the middle ground between engineering, which does not always have much of a research aspect to it, and doing like really abstract research that average people may or may not even be able to know about very easily.
Yeah, exactly. That's the other cool thing about batteries is that it's a very interdisciplinary field, we say. It's something for everybody, kind of. We in our group, in fact, we have physicists, chemists, people that do material science, engineers, process engineers. So we have students from all kinds of fields at Dalhousie University. And that's the nice thing about research in batteries, that you can approach it from many angles, and it can sometimes be very fundamental, sometimes be very applied. So it's really at the boundary between engineering, physics, chemistry.
I love that. I love anytime you get to do a little bit of everything. So, kind of switching gears a little bit, what is your favorite thing that you've ever gotten to do with science in general?
That's a good question. So, definitely we do pretty amazing things in the lab, and I'm always super excited about experiments. In fact, there's one experiment right after we're done here. I have to go to the lab and check with one of my students because I'm very curious about what comes out. And these are the nice things that you can do every day, when you do research and work in a university setting. But outside of that, I think my favorite thing was visiting the Kennedy Space Center in Florida and seeing an actual space shuttle that went to space, which is displayed there. This was pretty amazing. And they do a fantastic job at giving you the tour and showing you all the rockets and space shuttles. So this is a really awesome place. And I hope many of our listeners will be able to go at some point.
I will second that. I have also been there, and I also very much nerd out. I also am a big space enthusiast, I guess. So I also went to the Kennedy Space Center, and it was also probably one of my favorite things I've ever done. So
super cool, right?
yeah, it was good. I went when I was in high school though, so that was a while ago. But yeah, I love that that's your favorite thing that you've ever done of all this different stuff. It's so sometimes just spaceships are
Yeah.
just so.
Yeah, it's pretty amazing. And I mean, I'm not the biggest space nerd and so on, I would say, but I'm definitely excited about it. And I also find all the work that Tesla, well, I guess it's Elon Musk's other company, SpaceX, is doing on space travel and reusable rockets. That's really very revolutionary and pretty exciting.
Yeah, are there battery applications with those as well? Or is it not as much of a concern with the reusable rockets? It's more of a fuel thing.
Well, I guess for, coming up with enough propulsion to leave the Earth orbit, definitely this cannot be electrically powered or so. So you'd really still need to burn rocket fuel. But there are for sure lots of applications on the actual vehicles. I know that in the past NASA used fuel cells, which is another electrochemical concept, related to batteries, I would say, on their Apollo missions. And I'm sure, on SpaceX rockets, the crew cabins, and so on, there are lots of battery powered applications. And in fact, on all of our conferences, there's always representatives from agencies like NASA, and they report on these very crazy batteries that need to be able to operate on Mars, let's say in a rover. They need to withstand ultra cold, but also ultra hot temperatures, and they have some really interesting problems to solve with regards to battery technology.
Yeah, that's really cool. I guess one episode that actually has come out of this podcast was with Arad from Galaxia, and they do the satellite stuff, trying to make like cheaper satellites and all of those applications. That remind me of that because they were talking about all the different ways that things have to function in space and trying to do that cheaply and everything. And there may be a space systems engineer episode coming out at some point that
I will definitely
was very
listen to
cool.
that.
Yeah.
Nice.
So
Yeah, for sure. They need like solar panels and batteries, I guess, for their satellites. So this is another super cool application.
do you have any advice for anybody listening who might be interested in doing the kinds of things that you do? Maybe chemistry research or physics research or stuff with cars or batteries or whatever.
Well, I would say it's definitely always possible to just, come visit us at Dalhousie University. We do have high school students. We have summer internships for students who just want to, check out what we do in our labs. And then, as a piece of advice, I would say, it's always good to, I guess, be curious about, what you're actually dealing with when you have a piece of technology in your hand. Sometimes we take this totally for granted that we have, mobile phones that have all these amazing capabilities that we, didn't have, I don't know, 10 years ago or so. And there's a lot, you can find out by just being curious, asking people, researching on the internet how stuff works. But yeah, I mean, people are always welcome for sure, to just visit us in our labs and see what we do.
Yeah, and I'll say that if you're a little bit younger and can't apply for like a high school internship yet or something, at Dalhousie there's also things like Supernova, which is what we do, and we have science camps and stuff where sometimes they get visits from researchers or they get to go see labs and stuff as well. So that's something you could look at too if you were ever interested in visiting Dalhousie. Yeah, if not, you can learn so much from just being curious and looking at things online. Oh, I did have one question. Are you allowed to talk about the experiment that you're very excited to go look at after this?
Sure.
Or is it confidential?
Definitely. No, I'm definitely
Okay.
allowed to talk about it.
What are you so excited to go see?
So this is my student Sebastian, who is working on something super exciting. So sometimes with batteries, it's a problem that if you just let them sit around, then actually they don't hold their charge. So they do a process which we call self-discharge. That's pretty bad, and we want to avoid that because imagine you park your car and then you maybe take a flight, come back 1 week later, and the battery was full, but then when you come back, it's only 80% or something like that. That would be a drastic example of self-discharge. It's actually not as bad as that. But we're trying to find out why this is happening in battery cells. That's one of our goals to eliminate these so-called failure modes. So Sebastian, what he did is he analyzed the liquid electrolyte which is in batteries. So the batteries always have a positive side, a negative side, and then there is a liquid in the batteries that allows the ions, the lithium ions, to move back and forth. So he takes out as much as he can of this liquid, puts it into a machine which tells him the chemical composition, so which molecules are in there. So we found a molecule which is not supposed to be in there. So it's a suspect molecule, which really made us curious. It seems that this is formed chemically in the cell, and now we extracted this molecule and put it into another battery cell, and we want to see if we inject it in this battery cell, if it also does this bad self-discharge reaction that we want to avoid. So this is a way for us to find out about aging modes, and then hopefully in the future we can improve the batteries by creating this understanding first of what's happening and then fixing it.
Wow, so it sounds like you may have found the source of like a big problem. And
Yes.
had anybody found this before that you know of?
Not to our knowledge. So this is probably the first time that people find these so-called redox shuttle molecules in this type of battery cells that could be really responsible for self-discharge. And it's really like a detective work a little bit, So we're very excited that we finally found this molecule, and hopefully it can give us the answer to how to eliminate the self-discharge reaction that the batteries sometimes do.
That's super cool. I'm very excited to find out what you find out as well. I'll have to look it up once you figure it out.
Well, next time I come on the podcast, I can tell you if it was the molecule or if it was just if we were on the wrong track.
Yeah, we'll have the follow-up episode.
Exactly.
Hey, that's science happening in real time. That's actually very cool.
That's right.
So
Exactly.
You're doing the detective work as we're recording this podcast. Well, thank you so much again for joining me.
My pleasure, Jessica. It was fun.
And I'll let you go figure out what's happening with your experiment here.
And as always, a big thank you to everybody listening. For more science fun, you can check out our past episodes at bit.ly/whatdoscientistsdo, or you can find us on Twitter or Instagram at scientistsdopod. Do you have a question that you'd like answered by an expert? Send us an email or a voice recording at whatdoscientistsdo@superstaff.ca, and we might answer your question on the show. Thank you so much for listening, and I'll see you next episode. Bye for now. This show is made by Supernova at Dalhousie University, a network member of Actua. For more information on our summer camps, workshops, and more, visit supernova.dal.ca.